Session on data analytics with Python by Intellipaat. In this session, we'll take a look at what data analytics is and how we can use it to our advantage. Data analytics is one of the most important concepts, especially in data science. It involves using a lot of different methodologies in order to better understand the data that we have. So how do you get started with it? How do you deal with a large sets of data, and how do you extract information out of it using data analytics? We'll cover all of these and more in this session. So let's take a look at the agenda. But before we begin, please click on the subscribe button and click on the notification bell icon so that you never miss another update. Also click on the like button if you like this video, and in the comment section down below, let us know what technologies would you like for us to cover next. Also a quick note, if you have any questions regarding any of the things and the topics that we're covering during the presentation, please put them into the chat box and our team is there to help you out with any of the queries that you might have. Also, if any of the technologies, tools, and terminologies that we're using seem a little bit jarring to you and you don't understand all of those, don't worry. Stick with us till the end of the presentation and we'll guide you through some of the resources through which you can learn all of these things. So with that, let's take a look at the agenda for the session. So we'll begin by taking a look at what is data analytics. Data analytics is at the core of what we're trying to discuss here. So we'll try and get a good firm understanding of what data analytics is so that we all know what we're talking about and we're all on the same page. We will then move on to why data analytics. We'll try and understand why should you perform data analytics on any piece of information or data that you have. Why data analytics, in the sense that we're trying to explain why would you want to use data analytics and what benefit could it provide you. If you have some data set, why would you want to perform data analytics on it? Then we'll take a look at the components of data analytics. Data analytics involves multiple components, and we'll take a look at those one by one. We'll begin by taking a look at numerical computation. Then we'll take a look at data manipulation. And then we'll take a look at data visualization. These are the three major components of data analytics. Once you get started with these, then we can analyze any complicated set of data that we have. Although these are quite vast fields, so we're not going to be going in depth into all of those. Then we'll have some hands-on. This hands-on, if you are following along, you can follow along with us. All you would have to do is you need to install Anaconda with Jupyter Notebook, and you need to boot your Jupyter Notebook instance up and create a new notebook. Other than that, no libraries other than what are installed by default using Anaconda is required. So with that, let's take a look at what is data analytics. What is data analytics is going to be the foundation of what we're going to cover in this entire presentation. So data analytics is the process of analyzing data by performing several operations on it, such as transforming and cleaning, etc. Then drawing useful information from it. So if you've ever read about data science, if you ever read about the machine learning process, one of the steps in the entire data science and machine learning pipeline is data analysis, or data analytics as you might call it. The point of this is, when you have a lot of data, you need to first understand the shape of the data, the size of the data, what exactly are the several features inside the data that you have, how do those features correlate with each other, what are the features that are important to you, how do you extract those features, how do you remove any unwanted values, how do you remove any unwanted columns, and how do you fill values that are not available at the moment. So after getting the data, analyzing the data, and figuring out what are the mistakes that your data might have, only then you can go along and clean the data and transform the data. And then you have to visualize the data, and you have to perform a lot of different tasks in order to make your data more digestible and your data to be able to extract good, meaningful information out of it. You need to be able to perform data analytics in order to understand how to make sense of the data. Now, the process of data analytics, as we have already discussed, involves several steps, and we'll go through all of those one by one. But the most important aspect that we need to understand is that data analytics is about performing multiple steps on the data that we have, depending on what steps need to be performed. And those steps are going to transform our data, they're going to clean our data, they're going to change the shape of our data for the better. So we need to understand what we're doing to the data that we are performing these operations on, and what would be the benefit of using these operations. Then comes why data analytics. So we understand what data analytics is, which is basically transforming data, visualizing data, and all numerical computations and all of that. But Why go through all the trouble of analyzing some data set? I mean, you could just theoretically put it through machine learning algorithm using scikit-learn and create a model and then make predictions. So why go through the hassle of analyzing the data set that you already have? Well, data analytics is performed with the intention of drawing some conclusion from the available data so as to better inform our decision-making process. Consider the following scenario. You are a data scientist who is working in a hedge fund corporation. Uh, the financial status of your company is going down for some reason, and what you have is a lot of data about how the finances and auditing has happened inside your company. Now what you need to do is you need to then analyze that data in order to figure out where have the lapses been made in order to correct for those mistakes. This is where data analytics come into play. Now that was a bit of a hypothetical situation, but you can use data analytics to your own advantage as well. Suppose you are collecting data about the kind of books that you read, about the kind of books that your friends read, about the kinds of movies that you've been watching, about the kinds of movies that your friends and family have been watching. And what you can do using data analytics is then understand the shape of the data. What kind of movies do you usually prefer to watch? What kind of movies do your friends and family prefer to watch? What are the common similarities between you and your friends' taste in movies and books? And then how you can get along with those movies, and then next movie you can pick where the similarities happen. So let's say that you like action thrillers and your friends like action thrillers as well. So the next time when you want to get along with your friends and go to watch a movie, you can choose an action thriller movie. This could also work in your personal decision making processes in finances. If you are someone who invests a lot, you can take a look at the historical stock prices, analyze the data, and figure out if the price is going up or down. There are many aspects to data analytics. It's not just related to personal finances or figuring out how to do certain tasks. You can also take a look at your own finances, figure out where the most of your money has been going, and you can better correct for those mistakes. The best decisions are the decisions that are made with the help of data and understanding the problem at hand. So data analytics enables you to have a good grasp of how to use the data that is already available for you. In case you don't have any data, most probably many of the payment provider services and many of the services that you use in order to transfer money provide that data for you. All you would have to do is convert it into a format that is useful to you. And we'll take a look at all of that in a moment. Now comes to components of data analytics. So we've discussed what data analytics is, why it's useful, but now comes time to understand the components of data analytics. So data analytics is a multifaceted process. Multifaceted means it has several components to it. Now the process has multiple components as we've discussed. So let's take a look at them one by one. These components are just our interpretation of the components. You can, if you want to define a different criteria and come up with different components. First one is numerical computation. If you have some data that is of numerical structure and you want to get some information out of it, you might have to perform some numerical computations on it as well. To give you some context, suppose you have been taking some classes to learn how to play a musical instrument. Now you have not been taking those classes regularly. You have been taking them in short periods. So let's say you took one class on 1st of August and then dropped out on 14th of August. Then you restarted the classes on 3rd of September and then dropped out on 15th of September, and so on and so forth. So what you can do is you can collect the data of when you started and when you ended, and you can perform numerical computation in order to understand, okay, what was the longest period where you didn't quit? What are the durations of all the periods? What was the shortest period? You can even do remarks in which the shortest period you can remark what was the reason why you wanted to quit at the shortest period and things like that. So numerical computations are really useful when we want to perform some sort of a numerical analysis and computation on the data that we have, and we want to create new numerical components. For instance, in our example, we could take a look at the total duration that you spent in learning these things, regardless of the gaps in between. And using that, we can just subtract the end date from the starting date and then get the differences and then add them up. So we'll get the entire structure, and we'll understand how to do this in Python in a moment. So that's what numerical computation is about. Again, if you're trying to build something like a neural network or something like those, then those things also require a lot of numerical computation. And if you're trying to build them all from scratch, then you need to understand how to numerically manipulate some data. Then comes data manipulation. Data manipulation deals with having a data set and then figuring out kinds of things that you don't want out of it. So for instance, if you have a data set that has 5,000 rows and 30 columns and you only want 10 columns, how do you extract those 10 columns out of those 30 columns? If there are some missing values, how do you deal with those? If there are some outliers, how do you deal with those? If there are some values that are of different scales. So for instance, if you get data from international sources, somewhere people are using for measuring temperature, somewhere people are using Fahrenheit, somewhere people are using Celsius, somewhere people are using Kelvin. And for measuring length, measuring height, measuring weight, different scales can cause different issues. So in situations like this, you would have to manipulate the data to get them all to conform to a particular scale. So that's why data manipulation is so important. Data manipulation also deals with a lot of other complicated issues. These issues include cleaning the data, transforming the data, grouping data, segregating data, and also if you have some data where you want to filter the data, you can also do it using data manipulation. We'll take a look at how to do this in Python in our hands-on. Then comes data visualization. Data visualization is by far one of the most important concepts in data analytics. It is what generates those visual charts and flow charts that we can display on screen in presentations and make it more digestible for people who are not that literate in the data analytics process. So suppose you are going to perform quarterly sales report on your presentation. Now, showing the numbers is not going to be very useful because it's going to be really difficult for everyone to see the number, analyze it, figure out whether the trend is going upwards or downwards, what have been the sharpest rises, what have been the lowest, steepest falls, and all of that. In case had you done it using histograms or bar charts or whatever, this would have been quite a lot easier for people to take a look at and grasp how it's working. So it depends on how you want to structure your data and how you want to deal with it. But in the basic sense, if you want to visualize your data, then it's going to be much more presentable and it's going to be much more easier for you to understand and for other people to understand. It doesn't require that much of mental computation and mental overhead. So now we've come to the hands-on aspect. Before we begin with the hands-on, do note that there are some of the concepts that we are covering might not be familiar to you, such as we are using pandas and matplotlib and Jupyter Notebook. In case these things are not familiar to you, don't worry. At the end of the presentation, we'll guide you through some of the resources. And if something that we're using that is not familiar to you in this context, then put it into the question box or in the chat box and we'll answer those questions for you. So now let's get started. So we have data analytics available for us. I have already created a Jupyter Notebook. I've called it Data Analytics with Python. Everything is done for us. All we have to do now is start with our code. Let's start with numerical manipulation. So the first thing, I'll just add numerical manipulation. Right. Now here I'm going to be writing some code. One of the best things about Jupyter Notebook is that you can write these notes, you can write code, and you can get the entire output of the code all bundled in a single file. So now I'm going to import numpy as np. Now it runs. So I have imported numpy. Numpy is the numerical manipulation library that is available from Python. It is one of the most popular ones. If you have used NumPy, then you know that it's quite popular and it's quite fast. What NumPy does is that it allows us to create arrays out of normal Python lists. Python lists store some unwanted information that are not useful during mathematical computations, such as the bit precisions and all of that. So NumPy reduces the size of the data and then allows us to do these computations quite easily. So for instance, if I have, let's say, two lists of numbers, so I'll call them x. X is going to be equal to 1, 2, and 3, and I have y, which is equal to 4, 5, and 6. If I were to add these two numbers, to do this on my own, what I would have to do is a plus b, and for that I would have to loop over all of these. So for x in, or another thing I could have done is just x of I plus y of I for I in range length of x. Now I have 4 plus 1 is equal to 5, 5 plus 2 is equal to 7, 6 plus 3 is equal to 9. Now that works, but as you can see, there's a lot of code to write, and this worked because I have the same dimensions. Had I not had the same dimensions, let's say 5, I get index error. Which is also fine because that's what you would expect, but it is a little cumbersome and a little difficult to do normally. If I had to do this using NumPy, then I could do NumPy, or I've done np dot, and as you can see, there are a lot of functions. I'll use the add function. I'll pass in 1, 2, 3, 4, 5, 6, and you get this. Another way of doing this would have been just to create an array, two arrays out of those. So np dot array x and I would have to reformat this, of course. Then for y, I have to perform y is equals to np.array 4, 5, 6. Now I am supposed to add these two, x plus y, and it's going to give me the answer 5, 7, 9. And this is a numpy array, by the way. So as you can see, the output is quite there. So these are the ways you can manipulate. There are many ways you can manipulate an array and do different kinds of things such as addition, multiplication, subtraction. I'm not going to go into all of those, but you can perform all of these tasks on your own. Now that we are done with that, let's take a look at how we can do data manipulation. Now for data manipulation, all I have to do is, firstly, I'd like to do it by hand. So let me just create a function named describe, describe. This will accept some data and will return a dictionary which will contain some description of the data that we have. Now what I want to do with the data that I have is I want to measure the count, which is the number of elements inside the data, mean of the data, minimum and maximum values, and the standard deviation. Now to do that, what I would have to do is firstly get the count, or if I want to do it right in the code, I can just do it this way. COUNT. Count is supposed to be equal to the length of data. Python makes this really easy for us. But after count, or other thing we have to calculate is the mean. Mean means the average of the data. For that, all I have to do is sum up the data and divide it by the length of the data. That's also doable. Then comes MINI, MUM, minimum. And for that, I can use the min function. Again, Python makes it easy. Although there is a lot of typing, and we'll understand why I'm doing it manually in a moment. Then you go maximum of data, and then finally, after minimum and maximum, we want the standard deviation. Now to perform the standard deviation, we have to write a lot of code. So let me just show you what the code would look like. But and if you were to write it in single line, this is going to be a little difficult for you to understand right now. But don't worry, we'll take a look at that in a moment. So to do that, first thing we have to do is I'll get the difference between the mean and the values here. So x minus, and the mean of the data is calculated like this. So this is the amount for x in data. So for each element, I'm going to calculate the mean. Then I'm going to calculate the difference of each element from the mean. So this is done. Now after doing that, I want to calculate the square of it, or the sum of squares. So to calculate the sum of squares, all I have to do is for x times 2 in, or x times 2 for x in, and I also have to wrap it inside this. This is Python's list comprehensions in work. And finally, if I want to calculate how this is working, I need to calculate the sum of squares. So I need to calculate the sum here. So you get the sum of squares here. After getting the sum of squares, you need to divide it by the length of data minus 1. This is the formula for standard deviation. We calculate the sum of squares and do all of this. And then now finally all we have to do is perform the square root. So for that I have to import math.sqrt, or I can just import math. And here all I have to do is math.sqrt, and that's done. So now that I have the data, I think there's some invalid syntax because I didn't put a comma here, comma here, comma. So always put a comma in the dictionaries. Now let's just describe some data. 5, 10, 25, 7, 8, 9. Run this. This is the data that we're getting. So as you can see, just to calculate all of this, this took a lot of time. Now if I wanted to expand this into a function, I could, to clean it up, just to make it a little more readable, but this is how basically it happens. Now, after doing this, if I wanted to do something similar to this in using other libraries, I can just import pandas pd, run this pd.data frame. Inside the data frame, after describing the data, what I want to do is I want to create a dictionary in which the column name is data, and the data that we're passing here is also going to be the same. So if I do this, this is the data frame that we get. As you can see, this is the column name of data, and these are the values. If I want to describe the data now, I can use the describe function, and you can see it's giving me all the data that I want. As you can see, we are getting the count to be 6, mean to be 10.6, standard deviation to be 7.2295689. We're getting the minimum value to be 5, maximum value to be 25, and we get the 25th, 50th, and 75th percentile as well. So this is how it works. So instead of me having to do all of this, you can see this is done quite easily, and I didn't have to perform a lot of different complicated mathematical processions. As you can see, the code above is quite long, and I could have even gone longer if I had included 25th, 50th, and 75th percentile. And again, this code is something that you would have to maintain and you would have to write, and this would be really typical. But here you can do it quite easily. Now let's take a look at how we can work on some real world data set. So for that, I'll have to import some data. I'll go to the top here again. So from sklearn.datasets import load, and you can load different kinds of data set. I'm going to be loading the load diabetes function. This is done. Now if I want some data, I'll just use the load diabetes function, get the data. This is how you work with real world data sets and how you convert it to data frames. Firstly, analyze the data that you have. So this is the data that we have. We have keys. This is the dictionary. We have a data key which contains all the data. We have a target key which contains the target values. These are the things that if you want to create a model, things that we would want to predict, which are the diabetes level of a person. We have description of all the particular numbers. We have feature names. Feature names are the things that we want to use, and this is the data file and target file. So these are the things that we have right now. Also, if you want to use some data, you could also, instead of using this data set, I can also show you some other data set. Let me just show you. There are a lot of data sets available for you to use. This is load diabetes. You could also load and press load Boston. Let's take a look at Boston data set. It's a little larger, so we can take a look at that. And now if you take a look at this, this is what it looks like. It's the same shape of the data. We have data, target, we have description, feature names, and so on. So after having that, how do you convert this to a data frame? That's the main point here. So to do that, we have to just create the data frame. Firstly, I'll just assign it to df, create a data frame. Inside the data frame, I want to pass in some data. So I can just do data, and I can either pass in as a dictionary or I can pass in directly. So I'll just pass in directly. So this is what the data would look like, and we want the columns or the column names to be equal to data.feature names. Now if you take a look at the head of the data, this is what it looks like. Everything is there, but notice the target is not there. We need to add that to the data set as well. So target is equals to df.data.target. And now we take a look at the head of the data again, and now we have the target as well. So everything's working. Now let me just remove this so that we only have one of the interpretations of the data, or the latest one. Now we can perform several tasks, such as, first let's try and describe the data to understand the shape of the data. So the shape of the data tells us that we have 506 rows of data, and these are the columns. For each column, it's giving us the maximum value, the minimum value, the standard deviation, mean, median, mean and count, and median is the 50th percentile and whatever. So you can take a look at it, analyze it, figure out if something is off base. For instance, if there was a column named age and the minimum value of age was -5, then you know that -5 is not a valid value and you have some incorrect values. Now let's take a look at if the dataset contains some null values. So null values basically mean missing values. These are values that were not recorded when the dataset was being created, and that could lead to some issues when we're creating a model. So as you can see, there are no null values in our dataset, which is good. That means there's no cleaning that needs to be required. In case you had null values, then you would have to figure out how do you want to tackle those. You could either use to replace all the missing values with 0, or with the average of the column, or if there are a lot of 90% of the column values are missing, then you can just drop the column. That would be better because it would have less effect on your data. Now if I want to get a particular subset of the data, so I want to take the first 1 2 3 4 5 columns, what I want to do here is df.ilog. Doing it without pandas data frame would be very difficult. I'll take the first 5 columns. This would give me the first 5 rows actually, but if I want all the rows and first 5 columns, then I can do it like this. And since it's a little big, let me just show it here. Yeah. So we have 1, 2, 3, 4, 5. So first 5 columns. We're not restricted to the first 5 columns. Let's say I don't want the first column. I want everything to begin with ZN. So there you go. And I can even expand it to be the 6th column. And there you go. So instead of we drop the first column, we get from here to 1, 2, 3, 4, 5, and we don't use the 6th column. So that's how this works. Now iloc is fine, but what if I want to use the column names in order to get the information? So I can use the loc. Iloc means integer location, loc means location. So I want everything from Zn to age. All I have to do here is I want all the rows from Zn to age. And there you go. There you have all the columns from Zn to age, and head would be the one. The thing to notice here is that when I go from Zn to age in this one, when I specify the integer locations, it will remove the age because it's exclusive of the end. So if I had to put, if I wanted age here, I would have had to put 7 so that it stops before 7, which is 6. Here, what we get is we get the age of the column. So now that that is done, we can also perform a lot of different kinds of tasks here as well. We can create filtering as well. So let's say that I want all the columns where age is above 65. There don't seem to be a lot of columns where age may be 65 above. So I want all the data frame columns, all the rows, or all the columns, as you might understand, that have the age column to be greater than 60. And as you can see, I get 321 rows out of 509. I can even change this. So let's say 75, and I only get 262 rows. I can even go further. Instead of 75, let's say I want 85. Now I get 210 rows. So as you can see that I can filter my data according to how I want to filter it. I can use multiple filters as well, and we can take a look at that later on. But this is how this works. So as you can see, the age column is here. We have 100 as well. So let's take a look at how many are there of 100. And we have a lot of values of people who are 100 years old. So that's it. And if you want to perform, this is a subset of the data frame, so I can describe the data set here as well. This is going to take a lot of time, but you can do it if you want to. Now, after getting the data, this is what the data set looks like. We have the maximum, minimum, count, age, whatever. So we have age, and the maximum and minimum are all 100 because all the values there are 100. So this is how you can get a subset and describe the data set there as well. Now, let's take a look at the final concept, which is visualization. So for visualization, we'll be using a library called matplotlib. Let me just, so I have to import matplotlib.typeplot as plt. Now I can use the same data in the data frame that we have, and I can visualize the data. So let's say that I want to visualize or create a plot. I'll use the plt.plot df run this, and this is what it looks like. So in the CRIM column, the highest values seem to be around 380. So that's what it looks like. Other than that, all the values are quite small. So after this, let's take a look at how we can get the histograms. So to do that, I'll just use plt.hist df age, run this. So as you can see, majority of the values of age are 100. We have the lowest values between 0 to 10, and then 20 they're higher. Then between 20 and 30 the values are slower, and as you can see, this is what it looks like. So this is how you can visualize. It makes for better interpretation of our data. It makes for better understanding of our data. So with that, let's take a look at what else we can cover. So when I'm trying to learn something new, an investment in knowledge always pays the best interest is a quote by Benjamin Franklin. And this always keeps me, and I hope every one of you, to motivated and to learn new things. With that, if you are trying to learn some new technologies and you run into some issues, you can go to our community site, intellipaat.com/community, where we offer, where there are like-minded people such as your peers who can answer any questions that you are having, or any resolve any issues that you're facing with a particular language or a framework. Also, if you want to learn something new by reading blogs, then we have our blogging site, intellipaat.com/blog, where we publish blogs regularly about a lot of different kinds of content, ranging from demystifying technologies to learning about new technologies, interview questions, career preparations, and so on. If you are more of a visual person, we have our YouTube channel as well. You can take a look at all the free courses that we provide there. With that, you don't want to learn all of these things, but you want to get certified, we have a solution for that as well. We have our Masters in Data Science online program that you can take a look at. In this program, you get to learn data science from complete scratch. You can learn data science using R, using Python. You will get to learn machine learning. Then we'll move on to deep learning. Then we'll understand how to process massive data sets using big data and Hadoop and Spark. Then we'll take a look at data visualization software such as Tableau. Then we'll take a look at how to perform data science using SAS. We'll understand advanced Excel, MongoDB, and MS SQL. All of these things are going to give you a master's certificate. This certificate is going to be really helpful to you. You'll get 53 projects along the way. So you have a lot of experience and you have built something that people can take a look at and understand, and you can describe to people what you have built. So there are a list of courses that are included in this masterclass. You can take a look at those. You can take a look at the testimonials. It's one of our highest rated courses. You can take a look at the course curriculum as well. It is accredited by IBM, so you will get a certificate from IBM after completion of this course, and you'll also get a certificate from us. These certificates are valid in several different companies, ranging from Nasdaq, Ericsson, Sony, Cisco, and others. If you have questions, you can take a look at our FAQ section. We cover thoroughly many different kinds of questions. In case your questions are not answered in the FAQ section, let me guide you through some of the resources where you can learn these things. But before that, if you wish to learn these technologies and you want to get 30% flat off on any of our courses, you can by using the YouTube 30 coupon code. We recommend that you use it as quickly as possible because this coupon code is not going to be valid for long. This is only for our YouTube viewers. So you can take a look at this coupon code when you try to buy a course, and you'll get a flat 30% off without any questions. With that, if your questions were not answered in FAQ, or if you have some other queries that you would like for us to resolve, you can contact us on the numbers that are mentioned on your screen. If you're more of an email person, an email is listed on your screen as well. Our course advisors are there to talk to you 24/7. And with that, we've come to the end of the presentation. Hopefully this has been informative. Thank you so much for joining us, and we'll see you next time.